On Wednesday, we introduced the Pandas module, which houses our series and data frame objects, and we got some practice with interacting with an object-oriented program design and the concepts of attributes and methods. We were able to apply this to our speed camera violation information in order to answer a question: how many different traffic cameras are we actually studying in this data set? What I'd like to do now is actually try to address the second and third questions that we have listed here, namely, what camera is responsible for the most traffic violations on a given day, and which traffic camera has issued the most tickets overall. I'd like to review just a little bit of what we covered previously, and one thing we certainly covered last time was the concept of attributes and methods. Most advanced data types will have attributes, which are more elementary data types that are just existing in the background and are part of this larger object. And they also have methods, which are functions or actions that we may wish to take on the data type. One example of an attribute of a data frame data type was its shape, or in other words, the number of rows and columns that it has. We accessed this attribute using the syntax name of the data frame followed by a dot, name of the attribute. The next thing we did is we gave an example of accessing a method of an advanced data type. We used the head method. We have a large amount of data, 118,000 rows by 9 columns, as we just saw, and part of the reason that we're using Python instead of Excel is we would like a lot of the capability and functionality of Excel, but we don't want to have to be visualizing all 118,000 rows at once. However, it's still useful to us to maybe get a glimpse of what that would look like visually in an Excel sheet. So a DataFrames head method allows us to see just the top of our data. Remember that methods are actually functions, and all functions need to have an open and close parentheses, and any parameters that we might need to pass to that method would need to go in between those parentheses. The head method doesn't require any parameters, so when we call this head method on this particular data frame, we just need to open and close the parentheses at the end. That's not required of accessing an attribute. If you ever want to see the last handful of entries in a data frame, you can do this with the tail method of a data frame, and it will show you the last couple of rows. We also saw some notation for how to access just a single row in a data frame, and that was to call the DataFrames iLock method, which stands for index location. So we use the name of the data frame followed by the dot, the name of the method, iLock, and then here we're actually accessing a particular row. So just like we would access the element of a list, we use those square brackets, and then we put the row number we wish to see in between those square brackets. When we print the 118,535th entry of the data frame to the screen, we see that it matches this row that we have right here. We also saw how to access a single column in a data frame. For instance, if we were interested in the camera ID column, as we were when we were trying to figure out the number of unique cameras that we had in our data set, we did this by using the name of the data frame, the square brackets notation like we're accessing the element of a list, and then the name of the column that we wish to examine. Remember that a column of a data frame is actually a series object. So right here in this row of code, we created a series object named cameras, and we assigned it a value, and the value that we gave it was this particular column, the camera ID column of the speed data data frame. Now a series object has a value counts method that we can call. If we call the value counts method of our cameras object and print that to the screen, what we can see are all of the different unique camera IDs along with the number of times they occur overall in our original data frame. So of our 118,000 rows, 1,154 of them belong to this camera ID, while 1,153 of them belong to this camera ID, and so on. So what we're actually looking at here, printed to the screen, is a list. And the length of this list is the number of unique cameras. So the way that we were able to find the number of unique cameras in our original data frame was by asking for the length of the list that's generated by calling the camera's objects value counts method.